In this video, we review the types of raw measurement data that can be used with NeuroDOT. We begin with a brief overview of HDDOT data, then describe the three specific file formats that NeuroDOT recognizes and the third-party tools that are required to work with them. Lastly, we introduce the NeuroDOT functions used to read and write each of these file types. Although this video includes some MATLAB-specific material, the background presented is relevant to both the MATLAB and Python versions of NeuroDOT, as well as cloud-based processing using the Oxy website. There are multiple raw data formats recognized by NeuroDOT. This includes SNIRF and NIRS, but NeuroDOT can also save and load raw data using a standard MATLAB mat file. The difference between these file types as well as their use in neuroimaging can be confusing, so we begin with a brief overview. The goal of optical data processing is to generate a volumetric representation of neural activity recorded during an experiment of interest. The starting point is a collection of emitter-detector light-level measurements sampled across the scalp. In contemporary imaging studies, a high-density array is used which may contain dozens of optodes. The array data, that is, the output of the data collection hardware, is stored in a custom and often proprietary format. As a consequence, neuroimaging software does not usually work directly with array data. Instead, array output is converted into a standard format. NeuroDOT documentation refers to such files as raw data because they contain sets of light intensity measurements. The designation differentiates this data from volumetric or surface data that is used elsewhere in neuroimaging such as NIFTY and GIFTY. Raw data appears at the start of a NeuroDOT processing pipeline. Volumetric data appears at the end. In order to process raw data, NeuroDOT must be given the coordinates of the array optodes as well as the array topology, that is, the source detector pair associated with each light measurement. This information is bundled in a raw data file as data and metadata. Such a file format is called a container. Three types of containers commonly used in optical imaging are recognized by NeuroDOT. These are described in the next section. A key design goal of NeuroDOT is to provide standard processing pipelines that can be used with a wide variety of data. To this end, NeuroDOT recognizes multiple raw data file formats that are commonly used in the imaging community. The first format is the shared near-infrared spectroscopy format, or SNIRF. SNIRF has emerged as the standard format used for optical imaging data. Support for SNIRF is included as part of the BID specification, which not only facilitates the development of analysis software, but also encourages data sharing. The second file format recognized by NeuroDOT is NIRS. This is an older format popularized by the Homer Analysis Toolbox and is still a common output option of many FNIRS and DOT systems. Lastly, NeuroDOT recognizes a raw data format referred to as ndot in the documentation. This is simply internal NeuroDOT data structures which have been saved as a MATLAB mat file. Data in SNIRF, NIRS, or ndot format can be analyzed using NeuroDOT. This not only includes data from a growing number of commercially available systems, but also a growing number of optical datasets which are publicly available on sites such as OpenNeuro. If you intend to work with SNIRF or NIRS, you must install third-party tools to parse these files. The necessary software can be obtained from the FNIRS GitHub repository shown here. However, because it contains linked repositories, you cannot download this toolbox as a zip file. Two solutions exist. First, you can clone the SNIRF repository using the recursive option, as shown here. When the transfer has finished, add the toolbox to your MATLAB path using the Path button in the command window toolbar or using the Add Path command at the command line. You can make the path modification permanent using the Save Path command. Alternatively, you can download zip versions of the SNIRF, EasyH5, and JSNIRFy GitHub repositories separately. After each download is complete, unzip the archive and add the toolbox to your MATLAB path individually. As always, you may need to first move the files to someplace publicly accessible if they will be used on a shared machine. NeuroDOT provides separate functions for processing SNIRF, NIRS, and ndot files. The input functions are shown here. To read a SNIRF or NIRS file, use the function SNIRF to ndot or NIRS to ndot. For data in ndot format, use the MATLAB load command. These functions parse the file and create internal NeuroDOT data structures required for processing. NeuroDOT data structures can be written as a SNIRF or NIRS file using the ndot to SNIRF or ndot to NIRS function. To save as an ndot file, use the MATLAB save command. The MATLAB help command can be used to obtain a brief usage summary for any of these functions. For more comprehensive documentation, including a description of NeuroDOT internal data structures, see the Data Organization and Loading Raw Data PowerPoint tutorials. Additional information may be found in the resources listed here. Feel free to contact the development team with questions or post them in the comment section below. Thank you for your interest in NeuroDOT.